Chapter 4 Functions, the building blocks of code. What exactly is a function? A function is a sequence of instructions that perform a task, bundled as a unit. This unit can be imported and used wherever it's needed. There are many advantages of using functions in your code, as we'll see shortly. A function in Python is defined by using the def keyword, after which the name of the function follows, terminated by a pair of parentheses which may or may contain input parameters, and a colon, signals the end of the function definition line. Immediately afterward, indented by 4 spaces, we find the body of the functions, which is the set of instructions that the function will execute when called. A function may or may return an output. If a function wants to return an output, it does so by using the return keyword, followed by the desired output. A function always returns something in Python, even if you don't explicitly use the return clause. If the function has no return statement in its body, or no values given to the return statement itself, the function returns none. The reasons behind this design choice are outside the scope of an introductory chapter. So, all you need to know is that this behavior will make your life easier. As always, thank you, Python. Now we know what is the definition of a function in Python. So, why use functions? Functions are among the most important concepts and constructs of any language. So, let me give you a few reasons why we need them. First, they reduce code duplication in programs by having a specific task taken care of by a nice block of package code that we can import and call whenever we want. We don't need to duplicate its implementation. Then, they help in splitting a complex task or procedure into smaller blocks, each of which becomes a function. Third, they hide implementation detail from their users. Fourth, they improve traceability. And finally, they improve readability. So, let's look at a few examples to get a better understanding of each point. Scopes and name resolution. Do you remember when we talked about scopes and namespaces in the first video, a gentle introduction to Python? We are going to expand on that concept now. Finally, we can talk about functions, and this will make everything easier to understand. Let's start with a very simple example. I'm going to create a new file called copyinglevel1.py. Here I want to define a new function, my function, okay, colon, then the body, test equal to 1, then print my function, comma, test. Notice here that this is defined in the local scope of the function. Okay, then I wanna say test equal to 0, my function, and print global test. Okay, and notice here that this is defined in the global scope. Okay, I have defined a test name in two different places in the previous example. It's actually in two different scopes. One is the global scope test equals 0, and the other one is in the local scope of the function test equals 1. If you execute this code, you will see this one, the following output, such as pi slash chapter 4 scoping. You will see that my function prints 1 and global prints 0. It's clear that test equal 1 shadows the test equal 0 assignment in my function. In the global context, test is still 0, as you can see from the output of the program, but we define the test name again in the function body, and we set it a point to an integer of value 1. Both the two test names therefore exist, one in the global scope pointing to an int object with a value of 0, the other in my function scope pointing to an int object with a value of 1. Now let's create another file called scoping level 2, okay? Level 2.py. We need here this code, and also I'm gonna say there something like def inner. I'm gonna say test equal to, which is inner scope print inner test. Let's hit top. I'm gonna change the name out there. I wanna say inner here. I wanna invoke inner function. What do you expect it will output after execution? In the preceding code, we have two levels of shadowing. One level is in the function outer, and the other one is the function inner. It's far from rocket science, but it can be tricky. So let's execute it. I'm gonna say pi 2, okay? And you got it. Apart of that, another thing to note is that Python gives you the ability to define a function in another functions. The inner function's name is defined within the namespace of the outer function, exactly as would happen with any other name. Okay, that's it, but what if I wanna change the value of test from the inner functions? If you wanna do this, you need another technique. Actually, it's a keyword. Let's create another file called scoping.level to non-local.py. Okay, let's copy all of them, and we want to work now with the global and non-local statement. A non-local statement causes the list identifier to refer to previously bound variables in a nearest and closing scope excluding globals. So if you wanna change test, you have to put a keyword before that saying non-local, like this. Remember that this is the outer scope, and this is the inner scope, but is the nearest enclosing scope, okay, which is outer, and of course this is the global scope. Okay, let's execute it. Okay, in this case it's non-local. That's because we have to define before and then assign it like this. Okay, the nearest inclusive scope is this in the outer scope. So if you wanna execute it, you will see that inner and outer outer print the same output. Okay, it means that this cells was assigned with 2 and this one was assigned with a 2 value also, and you can see that global scope was not affected at all. Remember that non-local statement works on enclosing scope excluding the global one. If you want to introduce or change the test value from local scope, we want to introduce to another concept with actually another keyword called global. Okay, let's do the same scoping dot level 2 dot global dot file in here, and we want to copy and paste against the same, but in this case we want to change this non-local to global. Okay, just that. Now let's execute it again, but in this case it's with global. Okay, I will see now that inner and global has the same value because are binding the same variable, but outer it was omitted, so outer is printing the same value that is defined in its scope, which is this is equal to 1.